Morning, everyone. How are you today? Fine? Thank you. Thanks so much for coming up to my session today. So just to give a quick intro about myself, I'm Kamesh. I work for Red Hat as a Director for Developer Experience, actively evangelizing on Istio, Service Mesh, Serverless, and other technologies. And my first European conference. And thank you so much for getting me here as well. And lovely talking to you people. I had a wonderful workshop a couple of days back and really interesting group of people there. So it's going to be people who are there on the workshop. It's going to be a little bit repetitive. But if you're new, not there in the workshop, it's all the things are here are going to be completely new, right? The slides are available here on the GitHub, the bit.ly link, which I have here on my thing. So you can just go there and then get the slides up from there. And anyways, it's going to be shared with you as well. And if you have any questions, please feel to drop me an email on this particular, my email address which I've given here. Also, you can reach out to me on my social handles, which is right there, my Twitter, my GitHub handles as well. Great. So this is the way I start this serverless session anywhere. So how many of you feel this is serverless? Right. So this is because I was surprised with this because I wanted to purposefully put this because the first conference, the serverless conference which I attended in India. So basically, I'm from India, so I attended that. So you don't know that, right? So when I attended this, somebody gave me a sticker for my laptop sticker which says that somebody kicking your CPU box out. I was surprised. You still do this? No. Right, so for serverless, it's nothing like that. This myth is busted now. Serverless there are servers. The only difference is that we do it on demand, right? Whenever we need it, we bring up the server, execute something, and then we go out. If you don't, it means that if you are a people or organization on a cloud, then it makes you easier because it reduces your cost because it's going to be built, executed, and scaled on demand only. So whenever I need it. For example, let's say you've been running a cron job, which is a classic case for a serverless scenario. Like when you've been running a cron job, so let's say it starts at 12 o'clock in the night, and then it runs for, let's say, 15 minutes until 12:15 and dies, right? For years now, we have been doing this in this way. We'll be running a server, which will be running 24/7 all the day, and then we'll be just executing only for 15 minutes. So which is kind of literally resource waste because we have been running the entire resource for the whole day. Right? In this case, what you're going to do is you're just going to execute, scale, and build only on exact demand. So that 15 minutes of time where a server is needed, maybe 5 minutes before or 5 minutes after, I'm just taking a hypothetical scenario here, that's where you might need your server to run. You might need your server resources, right? Otherwise, you can dedicate those resources to something else which can do the job for me. Okay? Right, so what does it mean? Why I need to do serverless, right? This is another important thing which we need to understand. Being in this conference, this is going to be a two-dimensional thing, where I'm going to see it's going to be a DevOps thing, right? The first and foremost thing is that agility in any environment, right? Being a microservices, in an era where we develop microservices, we always say something we want to be super fast, super quick, into production, CI/CD, whatever scenario you have, and then take me to production almost instant of time, right? That's something which we need to do. So that's where agility comes into picture. Agility is for both the developers as well as for the operators, right? So for which means that the typical DevOps stuff. And what next is event-driven cloud-native applications. So we have been doing cloud-native applications for quite some time now. But the thing is that how do I make multiple clouds interact with each other? For example, today the organizations, they are all in hybrid cloud scenario, right? I'll be having AWS, I'll be having Azure, I'll be having GCP, so you name it, right? So what happens right now is that how do I make AWS talk to Azure, or how do I make AWS talk to GCP, right? Some kind of a common mechanism so which we can understand each other, right? The only way we can do this is through events because you've been used to eventing kind of thing. So all we do is we drive event-driven cloud-native applications, which means that when I have, for example, I say I spin up a compute in EC2, and then I get some information, the metadata about the geography, the size, etc., to another thing in Azure so that it can do something with the data, right? We need to have a common metadata exchange format. That's what Cloud Event does for you. And then the third one is focus on business differentiation. So it's a very simple, let's take a very simple scenario, right? So when I was doing my workshop yesterday, 2 years before here, I actually literally spend around half an hour to 1 hour time just doing my setup, right? Set up my CLI tool, set up my this thing, set up another thing, set up your cloud, log into your cloud, get your credentials, etc., etc. But actually, if you see the time that the users spend on doing the actual exercises is almost the rest of the one, right? Let's say in 1 hour, they spend almost half an hour doing these things, and then maybe they take another half an hour to do the exercises, which means that I'm not creating any big difference business value here, right? So for business, everything needs to be quicker, faster, and I need to say, okay, I don't worry about how do I create my environment. All I know that I have an environment, I have a code at hand, I push my code, and the things work, right? And then they get executed in an environment, and the environment takes care of everything that's required in spinning up your server, giving it compute, giving it memory, giving it CPU, whatever you want, and even disk spaces, and then it executes and then comes down, right? I don't even need to worry about shutting it down. Right, that's what is big difference in making a big business differentiation, because I need to know how do I actually do that, right? I don't need to worry about, as a DevOps guy, I don't need to worry about that particular stuff. All I want to know is like how this actually works for me, right? And then again, the third point is consistent and scalable operation, right? So any given, since we talked about hybrid cloud, again, if I go across any cloud, I should have the same mechanism how it scales up, how it scales down, vertically or horizontally, and I should know about I need to know about those things beforehand. That is a super critical thing when you're on a hybrid cloud environment. That's what even this does, consistent and scalable operations across the environment, right? Hybrid cloud environment. What essentially is all drills down to use for your resource and cost optimization, right? So when you're on a DevOps era, the primary thing your guy asks you is like how much resource you have saved, how much money you have saved for me, etc., because end of the day, everything drills down to dollars, right? So that's what we do here. So resource and cost optimization is one of the prime important thing why we need serverless, right? We don't want to waste resources. We want to be good to the mother nature as well, right? All right, so what it leads also to me is to talk to you about few things. The typical standard architectural styles which we have been using so far, right? For example, like we used to be having services, which is a typical client-server model. What I do is like it's kind of autonomous and loosely coupled things, right? Which is we call as monoliths. And then we also have something called as microservices, which has popped up swing. People have started to do microservice where I have single process, single responsibility pattern to do something here. And then right now we are in an era where it's called a serverless and functions, where it's kind of single action ephemeral. What I call it as a single behavior pattern. Right, your microservice is a single responsibility, and then I'm making the responsibility might have multiple behaviors. I'm right now splitting the multiple behaviors into single behavior, right? The function technically executes a single behavior, right? And even your serverless function as well. But what's the problem is that we always land up in this problem, right? This has been in history in our software industry. So the reason is like, so we don't know what to choose, right? We are so happy that something new gets introduced, and we tend to follow that like blindly without even knowing that whether my use case fits in the scenario or not, right? So because of the invent of services, nothing was not. Still, I use some applications which are typically native to the OS. Still, I use those kind of applications along with microservices. And also, like once microservice is not, I'm not thrown away all my monoliths. So, and I'm still having monoliths and still combining them with microservices. Similar way, when functions are introduced, there is nothing that you have to throw away microservices or services, right? You have to make a conscious choice saying that what should be my architecture, whether my particular use case fits in services or microservices or functions, right? There could be a scenario, there could be an application which you'll be writing which can mix up all these three things together, right? So which must mean that when I introduce serverless, I'm getting introduced to serverless, everything works in serverless. That's not the way it works, right? That's why I put this thing here saying like when to choose what, which is the kind of architectural style you should choose whenever you want to say, okay, I'm doing this kind of thing which needs more complexity and then high control, which means that I need to go for the typical monolith client-server architecture. And then I feel that something which has low productivity, like the cron jobs or like kind of updates, which are trivial updates that you do on your systems. And then I can go with the productivity and low control, which means that I can go with functions. And if something is between, I want a portability as well as I want something in between these two things, then microservice is your choice. Right? So going forward, like just a word of recommendation or probably an advice saying that whenever you get something on serverless, just try to see if it really fits serverless. If it doesn't, then ignore it and start doing it in any other architectural style. All right. So with this intent, I just want to introduce quickly to Knative. What is Knative? Knative was introduced by Google, I think, in 2018, Google Next. This is what it does. It helps you to run serverless workloads. So that is a very important thing. Knative is not a FAS. People have an invention that it's a FAS. It's not a FAS. It's a platform that's on top of Kubernetes that gives you to run serverless workloads, right? And how does it does it? It also has some essential base primitives. We'll talk about base primitives in a second. And then it also provides a set of middleware components which kind of helps you to run your Kubernetes application as a serverless applications, right? So again, Knative is just a platform to run your serverless workloads, right? So what does the primitives means to me? For example, you could be an organization which will be having some vendors like you have, which will be bringing in digital experience, functions, event sources, and build tools. And I want a way by which I can actually integrate that into my underlying Kubernetes platform, right? So how do I do this? Like, see, if you see, Knative gives you the middleware components. Like, for example, it has a middleware component that helps a build. I think now it's moved into a different project. We'll talk about that in a second. And then we have something to do auto-scaling. How do I do auto-scaling automatically based on my load? And how do I do routing? How do I define my routes? And then how do I invoke them as well? That's also a very critical thing. And how do I define event binding? How do I bind my events, right? We have event sources here, and then I need a binding to bind it to a service, right? I need to have some mechanism to know, like, how do I bind event sources to event binding? And then last but not the least, you also need those observability, right? Since it's going to be distributed or any kind of thing, I need to know how it works, how it performs, etc., etc. All right? So what is Kubernetes? Already you know about Kubernetes. Kubernetes gives me all these things, and Knative nicely fits on top of those things, reuses those things effectively to make these things work for you in a serverless fashion, right? Any questions until now before we move further? All right. So what are the capabilities it gives to me? The very important, the first, probably I should call it the killer feature of this is that no pod, no memory, which means that I can scale down to 0 automatically. So we'll also see that in a demo. See, like, how do I automatically scale down to 0 even when there is no resource, there is no request coming into my pods, and it has a stipulated number of time before which it actually does that. All right. And also, like, I can also scale from 0. This is another one, like, after scaling to 0, let's imagine a case where I have got a huge spike, right? And then now I have to scale up to maybe, like, based on the spike, I have to scale up, for example, let's say I get 50 concurrent requests, I can handle only 10, then I have to scale up 5 more pods automatically, right? That's also done based on traffic spike. And built-in configuration and revision, which will help you to do blue-green kind of a deployment. You'll see that in an example. Like, what I mean by here is Knative is essentially based on 12-factor app development, which means that it strictly follows all those 12-factor principles. So one of the things is being that any changes made to your configuration, I need to have a revision rolled out. So we'll see an example how the new revision gets rolled out. Yes, please.
How do you find out how many requests I'm able to handle to scale up? I could use custom metrics, or is there something?
See, actually, there is a default config map, which basically actually defines what's the default concurrency for your application pod. And then in the example, in the demo, I'm going to reduce that to show the spike, right? And then you can also have other metrics to measure. And then obviously, from the application perspective, you are the right guy to know, like, how much it can handle.
The object, I just tell there are 10 connections per pod.
Right. And then coming back to this, I get for every new revision is nothing but it's kind of unimmutable. Just imagine like you get tags. So I can go back to any last known good configuration if something not working for me with the latest releases, right? But by default, everything is released as latest one. So whatever the new deployment you make, that's the first one that gets executed for you, right? So we'll see that in a demo, live demo as well. And in cluster image building, I think this was there, but right now what I have done is like this has moved into a new project altogether. It's called as Tecton. I'll show that the URL of the project as well, which has built-in pipelines and everything, which means effectively right now, Knative will have just eventing and serving, right? And build is not completely moved out of the thing. Maybe it will be down the lane, but it has been moved out to a different project as such, all right? And the last but not, and you can also do traffic splitting, right? If you have been known to these kind of 75, 25, 25, 35 kind of canary releases, then I can also do those kind of canary releases with serverless as well, with Knative as well, right? I can define the routes, which can take what number of traffics it needs to do. And last, the eventing system. So how the event gets generated, how the event triggers to start an application flowing down as well. So we'll see an example of a cron job event, which fires an event every minute, and then you'll be seeing the service getting those messages, and then we can do whatever you wish to do, right? Great. These are the 3 building blocks. Probably, right now it was 3 building blocks. That's the original intent of me having it as 3 dwarfs. But unfortunately, now it has been reduced to 2 dwarfs now. So I need to change that. The first one, the Knative, which says that I need to do a build. So what does build do? Build basically takes your source and then build them and then convert them into containers. So people are used to OpenShift. So we have something called as S2I, so which basically does this work exactly. So we are done moving those things into Kubernetes. So where we want to do these things, and more of the guys like who are doing these things on Tekton or had guys doing all the nice good things which you have done on OpenShift, we're getting it to the community, right? So and then that builds your container. And now once I have the container, I need to weigh how to make the container to a URL, right? How do I access the container? So for accessing the container, I just use a serving component, which basically gives you a REST URL, basically, or I should say it's a URL which is given to your application, and then when the moment I invoke the URL, then it hits your service as well, right? And then last one is eventing, which gives you producing and consuming events, like event sources. We'll see I have a pictorial representation of that as well. So which kinds of produce and consumes events from the external world, and then react to those things with your services as well. Okay, enough of talking. Maybe I'll just quickly get into a quick demo to show you how it actually works. I need to sit and do this so that I don't hide you. So let me quickly give what this demo also does so that it's easy for you to understand. First of all, like everything in Knative is CRDs, so which means that they are custom resources which are defined by Knative. So you'll be creating a custom resource object, and then that takes care of doing the other related Kubernetes objects behind the scene. And then I just deploy my CRD, which is my service CRD, which we call. We'll see that in a second. Once the service CRD is created, like it has something called as Knative service that gets created. We call them as KSVC, Knative service. Once the Knative service is created, it also goes and talks to HPA, right, behind the scenes. So how do I scale and scale up and scale down? So the horizontal pod scaler comes into picture. And then what this basically does, it starts to deploy your pods, right, via the replica sets. I have a deployment gets created. I have multiple pods again my deployment based on a replica count. It also does something like revision, right? I told you it follows 12-factor. So I need to revision each and every deployment that I make. So any first deployment, any change to a deployment is revision automatically. And then once the revision is created, you also create a route, right, to access this application outside. And once a route is created, the route defines an endpoint. Basically, how do I access from the outside world via your ingress route or something like this. The moment, for example, let's say I have the service exposes www.example.com. And then I get through the ingress, which is a Istio ingress in this case. And then once the ingress is there, it reaches your endpoint. And then from the endpoint, it talks to your service. And the service gets distributed to any pod as a typical Kubernetes fashion. Right? This is how the whole thing works behind the scene. Let's see how in action, like how we actually do this. Let me go back to my end the show, go to my CLI. So the first thing I need to do, let's see if I have anything here. I don't have, okay. Watch. I'm just going to watch the namespace for the pods, just to show you how this is getting. Right now, we just have only 2 pods, which is all by default as per the the Knative deployment, which has already been done. So I'll just do a grep -i. Greeter is my simple hello world pod, which I'm going to deploy. You can also do is OC get pods or kubectl get pods. But I'm going to do this here. Is the font visible here, or need to make me bigger? Good? All right. The first thing I need to do, I'll just going to create a service YAML. What I need to do is like API, the first one is API version. As I said, it's a CRD, so which means that I have a CRD version serving.knative.dev / it's still in alpha. That's the first thing I need to do. Why? Because the second one is like I'm just going to give you something, a name called a service. The service is already there in Kubernetes, but the service that you're trying to create right now is a Knative service. Right? Just make it a bit bigger. Once I do this, I need to have a metadata. And then I give a name. I will call this as greeter. And then I need to have a spec, typically saying something, right? As I told you, right, it also has traffic splitting and other stuff. But by default, what I do is like I just now type run latest. I'll just change this in a second after another demo. I say run latest. Hopefully I got the spelling right. Yeah. And then I say a configuration. This is typically, can you imagine, map it like your configuration. That's what's defined by your 12-factor apps, right? So configuration. And once I have the configuration, I need to tell what's the revision template is. So what is a revision template is nothing but, if you are aware of Kubernetes, the revision template just takes a pod spec inside that. It does not have anything else. So based on any changes that happens within the revision spec, that's where Knative is going to start to create a new version for you, right? I say revision spec, and then if I get it right, it should be spec or template. Okay, let me stay for safer side. Yes, I copy this just to make it quicker, right? Sorry about that. So and then I have a different image for this. I say Knative tutorial. So a few things, important things to note here. Probably the liveliness and readiness probe here. It's highly recommended that any Knative service you deploy have the readiness and liveliness probe. The simple reason is being that, so whenever your service is dormant, right, and then I'm giving a request, it comes up. So the moment it comes up, if you don't have a liveliness and readiness probe, the service directly goes to the pod. But probably your application might not be up, so you'll be getting some 503s or 404s kind of thing, right? So we want to make sure that Kubernetes sends the request to the service only it's up. That's the best practice always, to have a liveliness and readiness probes. And this is what I said earlier, whatever comes inside this is exactly a Kubernetes pod spec. The Knative official documentation has all the things that can come inside this. So I have created this.
Routing should only be based on readiness probe.
The route?
The routing should only be based on readiness probe.
The route typically internally uses your service.
This is the readiness probe.
Absolutely right.
Just a quick question.
Yeah.
How does this service relate to Kubernetes service or Istio service?
I'll not talk about the Istio service because that's all about a big topic as that, because I need to talk a lot of things when I talk behind the scenes. So I'll tell you, like, once I create this, I'll show you that this also creates a Kubernetes service behind the scene. Right? You don't need to create that. So that's the whole idea of this. If you see this, the picture which I showed you here. So the deployment, basically, there is a Kubernetes service which gets created here. Right? It's already there. So since it's a CRD, custom resource definition, there's a controller which runs behind the scene, the Knative service controller, that takes care of creating all the objects for you. You don't need to create that.
The same as Istio, yes? I don't need to configure.
You don't need to touch even Istio also here. So it's just, this service, it just creates you only your Knative serverless service. Right? Correct. So let's try to apply this. OC, so you can use kubectl as well if you wish. OC apply -f. I say service.yaml. And then you should start to see the container getting created for you here. And then I'll also see, like, I'll also allow to show you like something like, I told you that there is something called as revisions. Watch OC get rev. So that, like, you can also watch the new revisions getting created. So there's first revision. So if you imagine here, it says generation 1, right? The revisions are based on generations. If you want to know which is the latest revision, it is the biggest one in your generation list, right? For example, you'll see one more deployment where I will update something, and then you'll see that the revision gets changed. Now we have 2 of 2 running here. The pod, which is here, just your revision name, probably will see this revision name and the pod deployment has some relation here. Let's invoke this. To invoke this, what I first need to do, I need to get this service, OC get services. You imagine, like, we use this Knative thing here, services.knative.dead. If you see here, serving and then services, right? That's the link which happens to CRD. When you have to call CRD and you have multiple objects, then it's always suffix that with your version, so that your CRD name, so that it's a fully qualified name. Just imagine, like, this is like your XML namespace here, and then this is your XML local object name, right? When you're calling an object the similar name within XML, so we'll probably use the namespace prefix to that. Just imagine like that. Now I have this, so now my service also gives me a URL here, right, to which I need to invoke the service. So let me copy this URL for further use case. I'll just export this. as a service URL so that I can use this here. Okay, I have a service URL here, and how do I invoke this? You'll see this. I have not touched this for last maybe close to a minute or so, and then you saw that it's automatically getting terminated, right? So because it's not used, so the service is not used, a pod getting terminated here. I'll allow this to terminate for a second. So that happens like by default, your Knative service has 30 seconds grace time and 1 minute stable window, which means that 1 minute and 30 seconds totally, that's a minimum thing which you can configure. It waits for your service until then, and then it starts to terminate the pod, right? So that's what happened here. So how do I invoke it? Now let's say I give a request, somebody comes and give me a request. I use curl.svc service URL. The moment I do this, you'll quickly see that the pod, another pod gets pinned up right now for you to get the service up and running. Okay, does it come here? No, yes, no. Okay, let me copy this here. I'm not sure, it just got exploded. Just the better that I use get pods, it's easier. Right, you'll have the service here coming up, and then I say curl. I get the response back from the service, right? So you saw something got terminated, but you see the new one got up right now because the old one died, and then I'm giving a request now, and then there'll be a momentary delay because the service has to come up and then it has to serve your request back, right? But that could be changed as well. We can use any other combination of other gateways to kind of make those things happen as well, right? So we have seen this, but how do I change or create a new revision, right? It's as simple as this. Let me say that I have this particular application which takes a bunch of environment variable. One of them is called as message prefix. Message prefix is okay, my name, and then I'll try a bit of German now. Right? Okay. Thank you. So and then now I'm going to apply this again. I say oc apply -f service.yaml. Now you see I already have, you'll see the revision, just watch the revisions as well down below here. And we have one revision which is generation 1, and we have one pod running right now. We'll allow this to terminate as well. Now when I say service.apply, a new thing is configured, and you'll saw a new revision getting deployed for you, right? Which means that because the principal idea is that here when I go here, I have added an environment variable which is a configuration change. As per 12-factor application development, any configuration change should create a new revision, right? That's a 12-factor principle. So because of that, Knative automatically creates a new revision which is generation 2 here, and then when I go back to this again and then call the curl, I get a new revision here, right? Which is kind of prefix I just added before my application, just instead of I, it says hello right now. And you also see the old one getting terminated right now. The old one is completely terminated because there is no request for past so much amount of time. All right. So let me now, what I do also do is let me see if my old thing works right now. We'll see get watch rev. I'm sorry. Right. I have one thing right now running for me. So that now what I do is like, you'll be wondering there might be some time where I'll be rolling out a new revision. And then I'll be thinking, okay, the new revision does not work as expected, so I need to roll back to the old revision, right? Or give it a new revision and then fix something and then get back to this. To do that, I go back to my app right now, and then instead of run latest, so what I should do is I should add something called as release. And then the release as revisions, which is an array. I can have any number of revisions I want. And then in this case, what I'm going to do is like, since we already get hello here, I want to go back to the old revision so that you can watch the change, which is nothing but this one here, because that has the generation 1, oc get rev. When I put oc get rev here, oc get rev, you get the revision by the generation numbers. So which means that the first one with the number 1, which is the descending order of the history, I just take this and then go back to my app and then say this is my revision which I want. right? Which means that right now I felt that my newest revision is not working well. So I want all the users to be redirected back to the old revision so that everything works well as before. So now, even though now the only thing you have to watch here is that I also want you to watch this, because now what I have done is pinning a revision right now. What revision I need to use, and this is not a configuration change. So which means that there should not be a new revision created. It's just a configuration inside the application routes gets changed. So when I say OC apply -f service.yaml, the same one which I'm getting apply right now. Once I do this, there is no change right now here, and then all the stuff is still there, and then you also see that the old pod is terminated. It's not available right now. So the moment I gave the request, the curl request again, so there is no new revisions, there is no new pod, the old pod is died. I'm going back to the old revision. Now when I do this, you will start the old pod getting created for you. If you see this, FQ8N5, which is a number, which is a funny number which Kubernetes gives. So if you see this, that's what getting created right now, and that's getting run. And then you got back the old one. You're no longer getting the newest one, right? If you're on the run latest, then you'll always get the newest deployment revision. If you're going to use pinned version, you're going to get the old one. All right? Any questions here before we go to the next one?
So this means you've got the replica sets running with the templates and having versions as an array.
Right.
Does it mean I can define multiple versions being able to run in the same?
Right, you can do that. And when you define the multiple revisions, then you have to manually define your route so that your distribution of traffic happens. Right. For example, I think if you go here, I think since you asked this question, let's see what the route has. OC get routes. Okay, and then I have one route here, -o YAML. Let me edit this so that it can be coming in my editor. Okay, I'll change this to okay. Maybe I'll change this to white. That is the better one. Theme. Okay. It's too bright. All right. So if you see this, what I've done here is like there's a traffic distribution which happens here right now, which says that I need to have this particular revision which you have pinned, and I'm doing 100% of the traffic getting routed to that. This is where it happens. If you have multiple revisions, then it technically distributes the traffic by default by round robin, or the algorithm that Kubernetes uses behind the scenes. And then we have to go define a new route in case if you want to do 50-50 or 75-25 or whatever distribution you wish to have there.
And is this part used to configure Istio, or would this work?
There is things which runs behind the scenes with Istio. I think as of now, it doesn't use anything out of the box, right? If you see the Istio namespace here, let me close this for a second. OC get pods -n. We have just two things, right? One, we have pilot just to create the virtual services, and then one we have the ingress gateway, right? These are the two things, which is a lean Istio deployment, what we call for Knative. So this is the minimum thing which you require in case you need observability, blah, 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 and other things which Istio gives you, then you deploy the full-blown Istio, right? In this case, I have done only the lean Istio deployment, which means that I just need only ingress gateway, and then I need the pilot, because to know the revisions and the configurations, virtual services, etc., etc. I think you should also get a virtual service, if I'm not wrong. OC get I'll see if that creates, or I'm not sure whether it's done behind the scenes. I think it's taken out right now. Usually earlier versions of Knative, they used to have this virtual service created against your object name, but they now removed it and kept it inside as well. All right. So how do I delete it now? So I'm going to do another deployment. So I'm just going to show you how do you delete this as well. So OC, the short form of getting Knative service is KSVC. Once I do this, I have one service here. So I'm just going to delete this KSVC greeter. This one is deleted right now. what I'm going to right now show you to is how do I do auto scaling, right? For example, I have an image here, which is called as a prime number generator. It uses there's a very Greek guy's principle of generating prime number. I forgot his name. I always have trouble spelling out his name. So what it's one of the slowest methods to generate a prime number. So I'm just going to use that because that will have the load gets piled up on your thing and then it starts to scale multiple pods. All right. All these things, I'll share the links later so I can just show the links as well. So I'm going to go back to the same service. I'll just use the same name just for convenience. And then I already have the image with me. I'm just going to update the image here. Go to my service YAML again, and then I'll just update this. I don't need all these things anymore. Just delete this. All right, and then I also do the run latest. All right, so I'm just reverting whatever we did for service spinning, and this is the image I'm going to use right now. And then let me go back to my thing, and then OC apply. If people will be wondering like why I'm not using kubectl, you can use kubectl as well. Okay. And then once I do this, the next one getting generated for you. And then what I'm going to do here is that I'm going to send a load right now. So let me send the load. Let me copy the thing for sending a load. I use a tool called a Siege. Siege is a tool to run your load test. You can use any tool you wish to do. And then I'm saying what I'm saying is that I'm just going to use a concurrency of 50. And then a thing of 30 seconds right now. So right now when I do this, what you'll be seeing right now is, come on. Everything works well right now. So you'll be getting all responses pretty quickly, and you'll be wondering like it's not scaling, right? Why it's not scaling? Okay. To know that, let me give it a few seconds for it to observe us, and then let's go back to I'll go to the console. Probably to show you that it will get all the responses back in a second. After this, it's status of waiting, and then once you go here, go to the projects, and then go to project called as Knative serving. I'm just going here, and then I have config maps. There's a config map called as autoscaler. I'm just going to grab these values from here, or I can also show it from here. I'm not sure. This is not so convenient to see. I'll grab it and put it here. Save, so that you get the syntax highlighting out here. Oh gosh, sorry about that. Save as cm.yaml. Okay, this is the config map. I'll just take off all these nasty things from here. You don't need all these things. You don't need annotations. And these also, you don't need these also. I'll just take these ones out. This is an example. You can also see that on the sources. So these are very important stuff which you need to notice. I'll just go back here, and then let's see what happened to my terminal. And we have all the transactions successful without any scaling, right? But what happens right now is, if you see your default config map that is defined by Knative serving for auto scaling, it says that it has a stable window of 60 seconds, which is the minimum time you can configure. You cannot go below this. And then you also have another thing called as grace period, 30 seconds. What it means is that people will be asking questions like, what happens if a request comes at the last minute, 1 second before the stable window, right? What it actually does is that after the last request, it waits for 30 more seconds for the request to drain down before to start terminating your request. Okay, that's what its grace period is. Again, this is the minimum value you can configure for this. That's the reason you will be seeing the pods getting terminated after 1 minute and 30 seconds or something close to that, right? You have to put these two things together. And the enable scale to 0, this is very important again. If I turn it to false, then it will not scale down. It will always be there running at one single pod always, right? And then if you see this is the one which is controlling your auto scaling. At least for this particular demo, this is very important. By default, all my servers are configured to handle 100 concurrent requests. right? Which means that my pod is right now is capable of handling 100 concurrent requests. That's the reason why you saw that it doesn't scale right now, right? So how do I change that? To do that, what I'm going to do is I'm going to delete this configuration just for clarity, greeter, and then I need to go here and add something like an annotation. I'm just going to copy this to save time. I go to the service. In the service, inside the revision template, right, I say this. Let me see, I need to format this. All right. Now I'm saying this particular service is going to have auto scaling target of 10. So which is by default the auto scaling target is 100. So now I'm saying that I want to go for 10, which means that now my pod is capable of handling only 10 concurrent requests. It can't handle more than that, which means that the moment it crosses 10, the concurrency, the system should automatically generate another pods, right? Scale up new pods. Let's see this. Let's apply this and see what happens right now. So I'm just going to say OC apply -f service.yaml. Okay, there is a issue here somewhere. Okay, sorry. All right, so now it got created. Let's wait for a few seconds for the pods to come up. So once it's done, so let's go back to our siege command and say like, okay, now I'm going to reload right now with all these 10 pods. Let's go back here. The session is running. I'll just make it a little bit bigger. Now the moment the request goes right now, you'll start to see the pods getting scaled up for you right now. And at the end of the day, like it should have 5 pods running, which means that there's 50 requests. I'm saying 10. So 50 by 10 literally means 5, right? If you're running a slower machines, it also computes by your CPU and memory also. It increases your number of pods, right? Right now, it's a fairly okay machine, which means that I'm getting 5 requests running right now, and then which is also giving me 50 concurrent requests against 5 pods. In this way, what I can also do is like I can scale up and scale down automatically. Right? I've not done anything. I just made my concurrency target. I know about my application. I can say to my application like what is the concurrency it can handle. The moment I set that up, your application Knative platform takes care of to scale up and scale down automatically. Right?
You're using the horizontal pod scaler of Kubernetes?
Yes, in this case, it's a mimic of it's by default horizontal pod scaler. But since I don't have my cluster so big, right now it does vertical scaling.
Yeah, but we could see the horizontal pod auto scaler.
Yes, we can also. There is also a parameter. I'm not and this is there's also annotation which can say that what kind of mechanism you need to have. Whether you need to have vertical pod scaling or horizontal pod scaling. I can also set those values as well.
Yeah, but this is HPA.
This is HPA. This is HPA.
So can you show the horizontal pod auto scaler so that we can find the configuration you did? Because this is done.
I've not configured the horizontal pod scaler myself. It's whatever done by Knative by default. I've not touched that. So again, so that.
Find it at least.
Okay, so that's a good one. And probably I'll just maybe the next session maybe I'll try to do that. But the whole idea is that developers need not know how to actually configure those stuff, right? Okay. And okay, that's a different story. So now what happened is like it scaled down back again. So I don't have any other things. So there might also be the last case which you'll see. There might also be a case where I also always wanted 2 pods to be running for me, right? Let's say that's called as a minscale. So I always want to say like, okay, even in spite of me going up and down, I also want always to have 2 pods running for me. So how do I do this? So let me delete this again. And then again, annotation based, I don't need to change anything. So I just say, if I'm right, it's called as minscale 2. So once I do this, what happens is that OC apply -f service.yaml. So you'll always see that once this pod is up, you'll also see one more pod coming up for you, right? Which means that there is 2 pods at any given point of time. Even if you scale up after this, once it's scaled down after the load, it stands only at 2 pods. It will not scale to 0. So right now what I have done is that I have not scaled it to 0. If you see in a second, like you should also see another pod coming up. You see that there. So by default, the first deployment which we made, we always had 1 pod. Right now, since I said its minimum scale is 2, which means that I always should have 2 pods given to me. Right? Whenever it goes less beyond that, then it goes beyond that as well. Right? It doesn't go beyond. Let me show that to you. Let's run the same load test again. You will see the pods scaling up right now. To handle the request, you'll get 3 more pods scaled up. But once it's scaled down and the requests are done, what happens is that it scales back to 2. It's not scales back to 0. Right? So in this way, what you can also do is like you can expect that in case if your application, you expect that there might be unexpected spikes, and I should always have something to serve the request pretty quickly, then what I can do is like I can have minscale configured so that it's always there so that my pods doesn't scale down to 0.
What happens if you don't have enough nodes?
If you don't have enough nodes, then automatically the scaling will not happen. It stops.
It stops till
Maybe whatever is possible, it can scale. So I was doing the same experiment when I was doing these demos. So I had a node which has a very less memory, less CPU. Then I was trying to scale up. It did not scale more than 2 pods. And then when I go and check my Kubernetes events, it says that it doesn't have enough memory, enough CPU for it to scale. So you'll be getting alerts on your events, Kubernetes events.
But to be honest, you can answer this just from Kubernetes level because this is the Kubernetes level. So if you got in test the autoscaler, you'll find out, oh, I've got some resources not able to be scheduled. It's not new nodes. But the funny thing is, if I would define a minimal number of pods, I don't need this.
You don't need this, right?
Then horizontal pod scale would be sufficient.
Yeah, if you find a minimum.
No.
Yeah, please.
No, I think it's not really the HPA which kicks in, it's an own autoscaler because this is based on concurrency and the HPA is based on CPU load.
No.
Right.
Wrong. Sorry, the HPA used to be on concurrency. Nowadays, the HPA is able to read metrics.
But
and most likely, this is the reason why I would love to see Jason from pod autoscaler. Where are the metrics from? Because if you deploy something like Kubernetes, you can use this record. And I would suggest that you've got something else providing this API for the HPA to give you a metric.
I think this is a future goal, but it's not the case at the moment.
So you've got your own?
There's an own, if you look in the Knative.
I think there's an autoscaler. There's an autoscaler here. So this is the one which is there. So I not went into this because that's good. That's totally digress the stuff. So if you see the loads here, so this is autoscaler here.
So this is a dedicated autoscaler, only
Yeah.
based for concurrency.
Right.
On parallel requests.
This is not for metrics.
But this kind of
What is this?
This is in Knative serving namespace. We'll get it's part of the Knative installation.
So there will be no HPA.
at the moment, not.
Okay.
As far as I know.
But I think there's a way. So if you can use metrics, because I don't use metrics here because I don't have Prometheus here. So if you use metrics, I can have another annotation based on CPU.
Yeah.
When I do this, then I have to define HPA.
So there's no special configuration for the HPA.
Yeah, okay. So now you just double the code.
Right. It's all done through the code. So for now, all right. All right. So again, I just have one more demo to show you about. I think I'll just skip this one. I did this. We saw about this, and we saw the demos. So and then I want to show you like how many Java developers are here. Okay, so the thing is that the Java developers, for Java people, the enterprise developers, I think 90% of the people we are. So we always say that Java fails on containers, right? The primary reason is that it's being C groups. I think they have fixed that in Java 8, 1.3.1 and above. It can understand, and by default, it's made by default with JDK 11 and above. So for that, we have to use experimental options, but after this, you don't need an experimental option. The other one they always say is that it's an alien in a Java serverless world, right? Java is called A because it boots slow, it's fast, it does not scale up quickly, etc., right? We have answers for that, something called Squawkus. I think my friend Roland is wearing the T-shirt as well, so he can show the T-shirt after that. So, so all the things which I are showing you, the experiments, auto-scaling and everything, all the images were running based on Squawkus. That's the reason you see that it's instantly up and running. Right? It was not slow, it was not even taking much memory up, and it was started much faster. All right? So if you see this, so it also has container optimized, super fast boot time, It has both JVM native mode, because it also has using Graal VM to kind of compile that into a native mode as well. So you can use all these stuff together. And if you like the session, if you have something interesting from this, just use this hashtag as well, because I want to say to people that Java is no longer an alien in serverless world. You can still do Java development. People no need to go to Golang. Golang people don't get it offending. So it's not that don't need to go to Golang. It's another learning curve avoided. All right. So, so this is something which you want to also see later. Maybe I have that in my slides, the links. You can just go there and then look at that as well. I'll probably skip build, because as I told you earlier, build has been moved away to a new project called as tecton.dev. If you just Google tecton.dev, that's where you get Kubernetes pipelines, CI/CD, etc., etc. So I'm just going to skip this earlier. And something which you have to understand is that the events are based on cloud event spec. Right? We are, I think, Red Hat, IBM, all these people were there doing the cloud event spec in CNCF. So the message exchanging, which is happening between the events and its messages, are going to be based on cloud event specification. So how does Knative does this? Maybe I need to throw you a little bit outdated image. I need to update that for triggers and brokers, which are new and introduced. For example, I could have a source. It could be anything. Let's imagine a message broker sending message somewhere. And then it also has a persistent storage, maybe to store the messages. Once the event is generated there, it lands into something called a subscription, which is an event source, which is defined inside Knative. So the event source gets configured with an event origin or something. And once the event source is there, I could have multiple subscriptions created on the event source so that my services can listen to those event source events. Right? Once the events is there, so all this moves through something called as channels, which is called as Knative channels. And then here is where your image gets converted into cloud event specification format. You don't need to do this. The moment the message arrives, Knative takes care of converting the message into cloud event specification and send it through the channels. The moment it goes through the channels, you will see those events getting pulled up by your services as well. Right? You have multiple services, multiple revisions. They can subscribe to those channels. The moment they subscribe to those channels, they start getting these messages. All right. You'll also see a quick demo on this. Yes, please. The channels by default, they have in-memory channel, what you're going to see today, but you can also have, there are multiple other persistent mechanisms that you can use. One of the things is Kafka. So you can use Kafka to kind of store those messages as well, the channel messages as well, so that's not lost. Right? I think there's a storage with the source as well. It could be a Kafka source, which is storing the message as well. All right? So another quick demo on this. About eventing. So and this, let me just do a cleanup. OC delete -f. YAML. So what I'm going to do right now is I'm going to deploy a new service. I just call this as event greeter. Okay, and then I'm not going to have all these annotations here. Just remove this off, and then I'm just going to go back to my old image. Because that's which is the one which handles the event sources. Right? And then I also need to have a source getting created, right? I'm just saying to go into sources, event.yaml. So this is the event source. So it's just a cron job source which fires a message every minute. And then you see there's a sync, which is your service. That's a subscription and tying up thing happens right now. How this happens is I go to serving. I say a sync is a serving service by name event greeter, which means that I also have an event greeter service that I'm deploying right now. The moment this service gets deployed, this starts sending a message to this particular stuff, right? You send the message from the source to the sync, right? The sync receives a message and starts processing the message. Right, the source sync in the typical eventing world, right, is exactly same. The one of the other thing I want to show right now is that I'm going to deploy the source first, and the good thing about Knative is that the source are not immediately active. The source gets activated only when I have the first subscription to the source, which means that again it's saving your resources. All right. So what I'm going to show you right now is just let me go here. I'll say OC apply -f. Let me see what the name I given for that. Okay. Event svc.yaml, that's the one? Yeah, okay. OC apply -f. And then I say event svc.yaml. And now you see I got the cron job job sources getting created, but you will not see any pods getting created right now, right? By default, you expect that there should be a pod that gets created. So let me also COC get pods to show you. There is no pods here, right? I have one default broker, which is a default setup that's done by this. So that's what I was trying to say. Now I say that I'm going to link the service right now. I say OC apply -f service.yaml. The moment I do the service gets deployed, and then let me also do a watch stern -c user container, and you'll see the cron job getting created right now because I got a subscriber right now available, right? Okay. It's saying that I have to stop. I say event greeter, and then if you see this, so I got a subscriber right now. And that's the reason when the cron job source starts to get activated, because I have a subscriber, I have to send a message to him. Until I don't have a subscriber, it does not get created, which means that it's also saving your resource without unnecessary creation. And this is what I said for Java people. If you're here, if you see this one, it started in install the features, Quackers. This is a container which is get started. I don't have the started in 0.131 seconds, right? So is that correct? No.
10 milliseconds.
10 milliseconds, I'm sorry. I saw the version. Right? So 10 milliseconds for a Java app to be started is something Java developers, even themselves, don't believe. Right? So we are making you believe that it starts in this is running, it's still running in JVM mode, not in a container mode. All right? And then once you start to get this, you start to get the cron message which is getting pulled up by this. The service gets a message automatically, and you can process the message as you want. Right? The funny thing about right now is this demo app will not terminate, because I'm always getting messages, so always pre-processing it, right? But in real world scenario, you will not be like that. The messages will be there, the message gets dropped, a message gets stopped, and then once it's stopped, it scales down automatically. You don't need to do anything else, right? Yes, please.
So when I have a Kafka cluster, is there any advantage to jump to this implementation? Or so what is the advantages when I have already a message broker in place and it's used by my service?
Now this is for the serverless kind of scenarios where the serverless events getting shared, right? I just send an event. You already have a message broker. You can tie your serverless services to your message broker, and then start getting the messages, right? For example, like let's say a case where I have a message broker running, and then I have a process. Let's say something which is an integration which is done, which runs only to listen to some messages and then process it, and then the message comes only once in maybe 1 hour or 2 hours or 3 hours, right? And for that, your entire integration needs to keep running, right? Instead of that, what you can do is like when you use a serverless kind of thing, I tie to my message broker. Now, once my job is done, it will scale it down. And then again, when I get the next message comes up and do it, right? Just saving your resource again, end of the day, right? Great. So I have a expert here, integration expert. So I was a little bit hesitant talking about integrations. All right. His Roland Haas. So these are some books. I think probably I'm just going to skip these ones. These are all part of the slides. I have some blogs published around the serverless eventing, building, and all of the stuff. You can just go look at the links are there in the slides. And if you also have a Knative tutorial here, so this is the one full-blown tutorial which I have written across sharing all these things which is done there, including integrations, camel-based integrations. And then also have Istio tutorial, which is again another tutorial. So we did this Istio and Knative tutorial a couple of days back on the workshop. This is a full-blown version. The workshop had a miniature of it. We also have other tutorials for you to share so that you can go there and then look at these tutorials to help your microservices and other base development, right? All right, so and that's pretty much I have for today. If you like, just give me a like in the tweet. I think my Twitter handle was shared right here. You just tweet there and then put my name across. And also, if you're a Java developer, I want you to put the Java hashtag as well, right? If you're not seeing the Java hashtag, probably I'll just go slides below because. So if you're a Java developer, I'll allow you to have this hashtag put along with the tweet if you like these. And that's it. So any questions I can take, or else we are good. Thank you. Okay, I like to take a last selfie if you wish, if you have, probably. Okay, I get hated myself. I'm not a selfie expert though. Selfie doesn't have a self, right? Thank you.